49 of those pieces put together would be the Earth, and that one piece left over would be the Moon.
That's a good way to think of it.
So it's still fairly large. It, in comparison to its parent planet, the Earth and the Moon, one of the largest of, planets with moons that are out there. How does the mass of the Moon compare to Earth versus the area? Knew somebody would ask me some math questions.
So it's a density kind of question, is
Right.
I think what they're getting at.
Right. So the moon's density is it is less than the Earth because the Earth has more of an iron core composition to it.
Well, I think we should get a little formal start to this now that it's a little past 9. We're just over 150 participants here. Then I can just turn things over to you, Jerry and Bob, to let you guys take it away. We're getting a lot of great questions already. Thanks again to everybody for showing up here. A lot of early arrivals, and perhaps more will join in throughout the next few hours. And again, for those late joiners looking at the moon here, and just in time for tomorrow's Observe the Moon Day. And we're with Jerry Dobeck and Bob Muller, some local astronomers at large. And I'm David Fenlon from Sleeping Bear Dunes. Just started a few months ago at the park, and just taking over the torch to keep continuing this work, these star parties, and this collaboration with the Grand Traverse Astronomical Society and Jerry of NMC. So yeah, I'm very excited to be here. Hoping we can learn a lot tonight and get to see a lot of cool stuff live. Despite the conditions, we of course would love to do this in person if we could. But this is better than nothing. Way better than nothing. And so yeah, I'm just thrilled to be here. So let's sit back and observe the sky here with Jerry. Jerry, I will go transfer to my other computer, and I'll just click the video off here. But yeah, are we heading off to another object next, or are we sticking with the moon for a while?
We're gonna stick with the moon for a little bit until we get a few people through here and they've had enough, and then we'll probably turn it over at Jupiter, and then maybe Saturn at the to go along with that.
All right.
Good evening, everybody. My name is Dr. Jerry Dobeck. I'm professor of astronomy at Northwestern Michigan College, head of the science department, and the director of the Joseph Rogers Observatory. I also wear the additional hat as president of the Grand Traverse Astronomical Society. So welcome to Sleeping Bear Dunes. For me, for us, it's the 50th anniversary celebration. True, we're about a month ahead because the actual 50th anniversary date is October 21st. But we're taking advantage of it now where we have some good clear skies right now to look at. And we're testing out something brand new, something I tried to set up for my astronomy students so that they could observe objects through the telescope very safely because of this COVID-19 pandemic issue. So we're using a video camera. Years ago, we tried to use video cameras to look at objects through the telescope without any luck at all. So now we're using a video camera. Sony came up with a light sensitive chip a couple of years ago, which allows us to look at deep sky objects. And this is the one we're using right now. So I projected from the video camera from an analog signal into a converter to turn it into a digital signal to project it onto the screen. And I'm doing a screen share through this Zoom session with you. So in a bit, I'm going to try and I may try and switch cameras. So we can get a little bit better view of Jupiter if we can, and then maybe some Saturn. And depending upon what's happening with our sky, we may try to get a peek at Mars as well. So I have a group of panelists here to help me answer some of these questions and to chime in with this. There's Bob Muller, Mr. Interlaken from the Interlaken Public Radio Ephemeris. Bob was one of the founding members of the Grand Traverse Astronomical Society. He's been our newsletter editor for the longest time recently. We also have with us, besides Dave, I've got Marie Scott still into this, and Don Flegel from the Grand Traverse Astronomical Society to help out with us too as well. So if you have questions, go ahead and put them into the question and answer portion of things. You can also utilize the chat for that, and we'll try and monitor some of these questions. Let's see, a reference of scale of things. Okay, reference of scale. A good reference of scale. So let's see. Is the moon roughly the size of Pluto? I'll go back to the scale for a moment. The moon is actually larger than Pluto. Pluto is just a little bit larger than about 2,100 kilometers in diameter. The moon's 3,476 kilometers in diameter. So it's about 25 to 30% larger than Pluto, than the planet Pluto. What is the biggest crater on the moon? And how was the moon formed? Okay, one of the biggest craters on the moon that we can see down here, and slide on down, move the image a little bit so we can see it. Clavius is one of the larger craters. So, and that's near our bottom portion of our moon. So let's head on down there and see if we can pick up part of Clavius. Just over on the edge. Not quite. So there's a very, very large crater off in this area over here called Clavius, a very, very large crater on the moon. Trying to recall the size. I thought somewhere in the range of 280 kilometers in diameter across, if I remember right. And that's one of the larger craters if we don't count the Caesar Mare. Some stuff in the chat too as well. Let's see here.
Yeah, Noah wants to know what the moon is made of.
American cheese. That was supposed to be funny, but no one chuckled. That's because everybody's muted. Okay, but my panelists didn't say anything either. The same things that the Earth is made of, except it really doesn't have composition like an interior mantle or much of an iron core. So it's more like the crusted material. So it's made of dirt, rock, basalt. It does have some precious minerals laying right on the top of its surface. The gold and silver are laying right up on top of the surface there. Some of the craters have dots in the middle. Those dots are actually mountain peaks. When an object, if you could follow my little cursor here, when this crater was formed, something struck the moon there, and what had happened is the center portion welled up and actually pushed up as a mountain peak in the center. It's a rebounding shock that occurs from the impact. A little bit about the history of astronomy and the observatory in that area of Michigan. Let's see, just real briefly, NMC began in 1951, and astronomy was one of the first sciences taught at NMC, and has been taught every term or semester since that time, -3. And the -3 was not for lack of students or interest. It didn't have a classroom to be taught in. So it's been taught here since 1951. The NMC barbecue that helps to fund things for the college, it had its last year, 2018, because, or excuse me, 2019. We didn't have one 2020, and that's ended now. There was a telescope that came from the barbecue that they tried to take out to Old Mission Peninsula in a van. It worked for a while, but then it didn't. So the idea of building this observatory came around. And then about 3 years after the start of the construction of the observatory was finished, finalized, in 1981, opened for students. And since that time, we've put through probably 150,000 people to this observatory. How the moon spins. The moon has a kind of a synchronous orbit right now where it rotates once in about 27 and a half days, but it takes about 27 and a half days for the moon to go around the Earth. So that's an average. Its orbit's elliptical and it goes faster and slower as it gets closer or further away. But it seems to be synchronous, so we see the same face of the moon because of that, because it's rotating at the same rate that it's revolving. Now, of course, as it gets a little closer to us, it's moving faster in its orbit, so we see a little bit more of one side. As it's moving further away, we see a little bit of the other side. So in reality, we see closer to 60% of the moon instead of just 50% of the moon. But for the most part, we're looking at just this one side. The craters that appear more in one area than the other, just from directional impacts. If you take a look at some of these craters down here, there's numerous smaller craters inside of bigger craters. Here's a whole string of smaller craters just by haphazard that they occurred in that region. Looking to keep up with the questions.
Looks like we lost Dave, Jerry.
Oh, yeah, I just saw that he's got dropped. I'm going to put him back into the panel here. Where'd he go? Oh, there he is. And I'm looking to see you guys help me out with the chat and the question answers. Hey, the backside of the moon is pretty too. Her scars tell a story. They sure do. The right side appears to be smoother. Wow, it got lucky. Those large seas or mare area are impact sites. And I think I lost Bob Moeller too here. Hold on a second. Put him back in. Can we see where they landed on the moon from the picture? I can show you approximately where, but we can't see the lander. There's a telescope on Earth that's big enough yet to see where the landing site is.
Can't see the flag.
Can't see the flag. We're starting to do some of that with my astronomy students to figure out how large of a telescope mirror do we need to be able to see the flag. And it's coming out somewhere around about 600 meters in diameter. Yeah, and we're trying to build a 30-meter telescope, so we have a ways to go.
Yeah.
Even with a telescope that size, we're going to need a very, very clear sky or no atmosphere to be able to do that, because the atmosphere helps to distort a lot of the images that we see. You can see some of that distortion from the atmosphere even in this image that we're looking at right now. If you look at the bottom here, bottom portion of this image, you can see how it waves just a little bit along this edge. That's atmospheric distortion. That's air currents moving over top of the Earth that will distort these images. And we see a little bit of that waviness again at the opposite lower corner, more prevalent than what we see with the radio waves or signal waves across the image. So, and that's from our atmosphere moving around. As it gets warmer or cooler air, that atmosphere will change and move around.
Getting a lot of great questions in here in the chat. Keep them coming.
Talk briefly about the type of astronomy courses offered at the college. Yes, we have, they're more or less 100 level courses. There's 3 courses that's taught. There's 2 that are direct transfer science with a lab, and 1 that's a direct transfer of credit, but not a science with a lab course. The summer one is a short course. It's 8 weeks long, and it's called Observational Astronomy. It's just basically an introduction to science through astronomy. It's kind of it's a combination of lecture and lab taught together, but it's not a separate lab course. Then we have 2 semesters of each of in the fall and the springtime. Our fall semester course is planetary astronomy, where we talk about the planets, just in brevity, because it's basically a 100 level course. And then in the springtime, something called a stellar class, where we try to avoid the extrasolar planets and getting in depth about the planets and talk more about the stars, galaxies, nebulae, star clusters. So each semester we have 2 sections of astronomy, and normally I would have 36 students in each section, so 144 plus the summer class, so we get close to 200 students a year. But we've cut back on the number of students because of COVID, and right now we're running classes of about 50 students each semester. How many people have been to the moon?
Great question.
Does anybody know?
That's something for the Google, but my guess is what, just on the count them on a few hands.
Yep, there's 12 people that have been on the moon, that have walked on the moon.
Even dozen.
Yep, all American astronauts that have been there. So, but the last time we were there was in 1972. It's been a while. 13, 12, not quite 13 yet. How often are moon craters created, and have we found new ones created? We have seen some bright spots. We've actually created some craters by dropping some rocket sections onto the moon. They've created small craters. We've seen some bright spots, mostly by amateur astronomers, and usually during meteor showers, that they will, it makes small impacts on the moon, nothing really, really large. Asteroids nearest the Earth. Right now, we don't have any that are in danger of hitting the Earth. We've got some near-Earth asteroids that are passing by several moon distances away from us. Not very big, but nothing that's coming in very, very close right now. But we keep an eye on that as much as we can. And yes, hi, Tom and Susan. How are we doing with questions and answers? I'm going to take a peek at that, see where we're at.
There's a lot going on. Yeah, I was about to ask you about the one from Maggie. If the moon is a rock, how did they get a flag in and make it stay?
Most of the surface of the moon is powdery on the surface, even though there's rocks spewed all over the place. So they noticed that the surface of the moon is powdery, and it's almost, they described it almost like a talc, that you could actually compress as you put your foot down and left boot prints. So they could push the pole down in deep enough, that would basically support the flag. The problem is, when the first flag was placed on the moon, they didn't think about this. The blast from the ascent engine actually knocked the flag over, so that one's not standing up. That's laying
Not even there.
Laying on the ground. So somebody will have to go back there and stand it back up.
It's got to be on the agenda next to the science the next trip.
Right. How does the moon
write the flag?
How does the moon create our tides? And actually, the moon helps create tides. It's the sun that creates most of the tides. So the moon adds to that because of the gravitational attraction of the moon. So we've got the sun pulling on the Earth, thank goodness, otherwise we'd go shooting off into space. But see, the water is more elastic than the soil is. So that's why the water rises and falls. Rises on the sunny side and falls on the opposite side because it has to fill in the voids. And with the moon out there too, works in conjunction with the sun to create the tides. So when we have the sun and the moon in the same location or close to it, like during a new moon, or even during a full moon when they're opposed to each other, we'll have the greatest change of tides, and those are something called spring tides. And during a first quarter and third quarter moon, the sun and the moon kind of balance each other out, and we have a lesser amount of tide called a neap tide, N-E-A-P tide.
So even though the sun's that way farther away, it's just that much bigger. It's pulling
About the
doing
mirrors we
most of the
left on
work.
the moon. Yeah, there's mirrors that we left on the moon, reflectors that we left on the moon, and we actually shine lasers from different locations, mostly from Arizona, up to the moon and measure the time it takes for the light to return back to the Earth. So we're actually measuring the distance from the Earth to the moon on a continuous basis. So very, very, very slowly, the moon is moving away from the Earth, and it's getting fairly close to about 3 centimeters per year, or just a little bit more than an inch every single year that it moves away from us. Have you heard there are people that don't believe we actually landed on the moon? What do you think about this nuttiness? Well, I had an opportunity to talk to Alan Shepard when he was up in the Leelanau County area filming a television commercial for AT&T. This was a long time ago. I think around 1989, 1990. And then, no, I didn't ask him what type brand of golf ball he shot on the moon. I wanted to know what it felt like to stand on the moon on another surface and look back at home. And even though he was there with another astronaut on the surface, he says he never felt so alone and desolate in his life, and was hoping that he could just return back home. So he shares some of those feelings, with us. I have samples. I have brought samples of the moon's soil here to Traverse City. It's been a while. Maybe I need to have those returned. Moon rock meteorite samples out of NASA's vault that they have in plexiglass type of a holder. So maybe I need to bring those back so we can take a look at those, and I can show you that the stuff that's the moon is made of is like Earth, except it's in different forms. So as far as did we really actually land on the moon? Yes. It'd be nice if we can return to the moon.
I think conspiracy theories are just, I don't know, it's like somehow more interesting that it's all, everybody's just keeping it a secret that that it never happened. The
Right.
amount of all the people involved with that, the fact that they could keep that under wraps that it never happened is
Right.
pretty funny to me. But
There's a question here. What type of telescope are we using? We're using what's called a Schmidt-Cassegrain. It's both a reflecting and a refracting telescope. It's got a corrector plate in the front that holds a secondary mirror. Its main portion, though, is a Cassegrain type primary mirror. So it's 16 inches clear aperture. It's a 17.25-inch diameter mirror. So mounted on a fork mount drive. So about a 16-inch clear aperture, I guess would be a good way to describe it. How was the moon formed? We honestly believe that the moon was part of the Earth, that something struck the Earth during its early formation and knocked a hunk of the Earth out. And as it started to move around the Earth because of a collection of material, that it collected together to form this orb that we call the moon. Okay, so where's the evidence of that? Well, the material that's on the moon is very much like the crusted material here on Earth. Along with that, if we take a look at this large area called the Pacific Ocean, and we notice from movement of plate tectonics that the continents have been drifting from a congealed area of North America, South America, tucked into where Africa and Europe is. And right now it's moving toward the Asia area. So the Atlantic is getting bigger and the Pacific is getting smaller. We believe that that continental drift across there is moving to actually fill in that segment that was dug out to form the moon.
now how does that telescope compare to, say, some of the other large ones around the country and the world? I mean, I think you mentioned some of the largest we have on our last call. That, I mean, is how much more powerful can they get than what you have?
Yes. So this telescope is just a little bit smaller than a half a meter in diameter, 0.46 meters in diameter. So some of the largest telescopes on Earth are 10 meters in diameter. So about
20 times.
20 times the size of this one. So where this telescope is, there's still room inside this 14.5-foot dome. There's telescope mirrors that are bigger than this dome, actually larger than the classroom area of this observatory.
And we do have the 25-inch, Jerry,
Yep, which is a little bit larger still.
and about 8 feet long,
Wow.
which we do bring out to the dunes there when we're having the live star parties there.
That's what I was wondering. A little more mobile than the one at the observatory. Chris Kobeck asked, is there water under the surface of the moon?
We think we may have discovered water or ice at the craters in the polar cap regions, both the North Pole and South Pole polar caps. Some of the orbiters that are going around the moon is seeing possible evidence of ice in those craters. That would be possibly the only place that we would find something of water or ice on something like the moon. So as far as on the surface or below the surface, probably not, simply because the heat there that created a lot of these craters on the moon. So there was a question about, back to the question about mass and density of the moon in comparison. The moon is relatively, since it's made of crusted material, it probably doesn't have an iron core, and if it does, it's really, really small. Its mass in comparison to the Earth, and a percentage-wise, it'd be around about just under 2% of the mass of the Earth in comparison. Does the moon's gravity distort the telescope's view of other planets or stars? Not enough mass there to really cause that, like what we would see during, like the sun has, or when we see during a solar eclipse. During a solar eclipse, that helped to prove some of Einstein's theory of relativity, that space can actually become distorted because of massive objects. So the moon doesn't have enough mass to really cause something like that to occur. Oh, why she can bring the moon inside?
Lulu's question there, you reading?
Lulu's question. It says, Lulu, she's very excited. Okay. Why she can bring the moon inside?
She can't, is what she's asking. Why can't she?
Why can't she bring the moon inside? Well, you see, the moon is a really, really big place. The moon is a little bit larger than the state of Texas. So if you had a house a little bit bigger than the state of Texas, you could probably fit the moon inside. Lulu, as I said, you have to take a big piece of Play-Doh, or not, it doesn't even have to be that big. Take a piece of Play-Doh and break it up into 50 pieces. Then take 49 of those pieces and make it a ball again, and that's the Earth. And that one little last piece is the moon.
Jerry, we got a good question that I think you explained last week in our call. How did you get a camera in front of the telescope so clearly? So maybe you can explain that.
Yeah. So as we got into this pandemic, I was trying to figure out a way how I can get my astronomy students in the college class to be able to see the images that come through a telescope without looking through the eyepiece of a telescope. And as I dug around, I found where some people had taken a security camera chip, a very, very light sensitive security camera chip, and mounted it into an adapter that will actually fit inside of the telescope's eyepiece. With that, we're actually able to take video images of faint objects and project it onto a small screen. Well, if we could project it onto a small screen, I took that and found a way to project it turn it into a digital signal so that we can see it on this computer screen. The wonderful thing is I can actually send it from this dome down into the classroom and project it using a data projector into the classroom and show my students right during the evening times so that they can see what this telescope sees in a live image. So what you're looking at right now is a live image of the moon taken from the NMC Observatory's telescope. I'm going to move it up so we can look at some MARI in the other areas. But we're seeing a live image of that. So we could also take a look at other places on the moon. This brightening down here, this is the crater Tycho that we see often these bright rays emanating up more prominently during a full moon. So those bright rays moving along. So let me move this to so we can take a peek at that area up here. And someone had a question about where the guys landed on the moon. So I'm going to stop back up this way. You're over here. And the Sea of Tranquility, Mare Tranquilis. So the Apollo 11 guys landed in this area over here as part of the Sea of Tranquility.
So is a question I would have here, is there really a dark side of the moon, or is that, I mean, what is the relationship of that?
No, and that's a question I often I ask my astronomy students that is there really a dark side of the moon? Since the moon does rotate, every part of the moon at some time does receive sunlight. So there really isn't a complete dark side of the moon. Pink Floyd was wrong. There is, however, a far side of the moon. So right now what we see as the daylight part is a portion of the moon that the sun is shining on. And I'm going to mute myself for just a moment because I'm going to rotate the dome just a little bit. We're starting, if you see this black line along the side here, on this side, is actually part of the shutter here at the observatory. So because the Earth rotates and so does the moon, I need to sometime move the shutter. So I'm going to do that for a moment.
Yeah, I can see it creeping in.
Okay.
Marie's saying congrats for an excellent program. Thanks so much.
Okay. I see a Scott in there, but I don't know if that's Scott Tucker or not. I don't see a last name.
Oh, maybe he's incognito.
It could be. So we're running about 167 people into this session right now. So yeah, is there a recording that we can access after the Zoom meeting? Unfortunately, we're not going to be able to watch the whole thing. So I'm going to, Dave, I'm going to leave that up to you because we'll have a recording, but I'm going to turn it over to Sleeping Bear Dunes. I'll keep it, as well for a record, but can we share this?
Sure.
I think
sure.
we can.
Yeah, that's the hope. With the 50th anniversary, we're hoping, I mean, for the one that we were going to have on October 21st, the actual day, we were going to put that up. I don't see why we couldn't do that as well with this. It might take some processing, make sure we have some subtitles and whatnot, but yeah, I'll definitely look into that. So I see you're already recording. I haven't been recording on my end, but
right.
I'm recording.
Yeah, I'm recording the entire session of that.
All right.
Yeah. On the water subject, tardigrades on the moon. What does that mean for research and future experiments? What that does mean is maybe if there is ice areas that we could have water, that's where we probably want to land and put up a space base of sorts in that location. So when it comes to travel out to other planets and other locations and things, water becomes the big factor, because it's the heaviest stuff that we need to take along with us to survive. So that's why we're excited to find water in different locations, like below the surface on Mars. So that means less material that we have to take with us at that time. So, because for water, we can turn it into breathable oxygen as well as for fuel. So a whole combination of things.
And tardigrades, for those that don't know, that's the little water bears, right? That they can survive just about anything. And
Yep.
I think I've read that they believe they might even be aliens in some, like they could have come over on asteroids, or there's theories of how they got here, or they might have evolved here. But that is a pretty crazy little critter that they put up into space and see all the different conditions it can survive. Extreme cold and no gravity, obviously, for a long time. But they're very tiny. Water bears, I think, makes people think that some bigger creature. They're microscopic.
Right, or that it's moving all around.
Yeah.
How much do we know about the dark side of the moon? Not a whole lot. There is a rover there on the opposite side of the moon, rather than calling it the dark side, the opposite side, that I believe that the Chinese have landed there, and is conducting some experiments and doing other things. Excited about Project Artemis? Oh, you bet. Will we get to see Jupiter?
Oh, we get Saturn, Jupiter.
Saturn, Jupiter. We'll turn it on to Jupiter. Let's see what happens.
Bring on the Jupe.
I'm going to mute this as I move some things around. I'm going to mute me so that I can still hear you guys, but so that
So Project Artemis are they cooperating with SpaceX for that? It's got to be some kind of some relationship there. This is the first time hearing of it, though. I feel ignorant here. Where exactly are you viewing from? This is from the Rogers Observatory in Traverse City. And as Jerry was explaining earlier, he's got a little setup on the telescope so you can actually see the live feed.
Mm-hmm. Okay, we have Jupiter and a couple moons here. Jupiter is really burned in.
Adjusting some settings here. So, I mean, Chad, it's smaller than I thought. Yeah, it's a little bit further away from us than the moon.
Can we still make out any of the moons?
With the moons and with this particular camera at this ratio, because it's so light sensitive, to pick up the moons, it'll burn in Jupiter just a little bit.
I looked up the locations of the moons, Jerry. They're all to one side of Jupiter:
Yeah.
Europa, Io, Ganymede, and Callisto.
So I'm not quite sure if I can grab that. We'll find out. We'll try something else here.
So, Bob, or whoever could answer this, this is visible right now on Earth here too. If people wanted to look up and try to see it.
It's in the south. All four of the Galilean satellites are on one side of Jupiter right now.
And Saturn,
We have
Saturn is just to the left.
Europa just to the left of Jupiter, and then we have Io, Ganymede, and Callisto maybe a little dimmer, a little farther off the, oh, right at the edge of the screen on the left is Callisto.
Hmm.
4 moons Galileo saw back in 1610.
So is that Io that's right at the edge of Jupiter there?
Yeah, it's kissing the edge of
That's
Jupiter.
Europa.
Oh yeah, Europa. You're right, Bob.
That's Europa.
Yeah.
So let me see if I could.
I'm cheating. I'm running stellarium here in another window.
Now I'm going to try and move that just a teensy bit more. Let's see if we can pick up the 4th moon.
Yeah, right off the left edge there.
What do we have? About 68 moons altogether, or are there a few more they found?
Can't quite pick up the 4th one with this right now.
Yeah. I've lost count as they keep changing all the time.
I think we're actually approaching close to 79 for Jupiter.
Really?
Wow.
Yeah.
Yeah, well, it's on the outer edge of the asteroid belt, so it's just picking up all sorts of trash.
Right.
It becomes satellites.
It has so much gravity, it just pulls them in.
Yeah, well, it's throwing its weight around. It's got more mass than all the other planets and asteroids and everything in the solar system times 2.
Wow.
Twice as mass as for everything else floating around the sun.
Yeah. And it's a matter of these satellites that we've sent out to Jupiter to investigate. We're discovering more moons that Jupiter has. It's got 4 fairly large moons and a whole bunch of little ones. And the growing number is from the little ones that are being discovered that really are orbiting around Jupiter. So while we're going into planets, is everybody patient enough? I'll try to do a change in cameras here, if you're patient enough. We'll lose, of course, the ability to see the moons, but we may increase the ability to see Jupiter.
That's good.
Well, we want to try for this?
Yeah, unlike the eye, these electronic devices can't see both the face of Jupiter and the moons at the same time. That's
right.
One advantages our eyes have over all these electronic stuff.
Yeah, unfortunately, some of these cameras, the field of view is relatively small, so we don't have the luxury of being able to fit everything in that we can with a wide field eyepiece. And again, the field of view of the eyeball is much better than the field of view of these cameras. So, but let's give it a try here. Let's see. Okay,
Yeah, somebody mentioned that you can actually see the moons with the pair of binoculars, which is true. If they're far enough away, especially Ganymede, it's the brightest of the moons. And you have a pretty good shot at seeing those, especially if you hold your binoculars steady or lean up on something that you can um, keep your binoculars steady.
and let's see. I'll let you guys keep up with the chat stuff.
Okay.
And for a moment, I'm going to mute myself. I'm going to mute myself and change these cameras around. So, but I'll let you guys keep up with the chat and the question.
Okay.
Somebody just asked, can you see the red spot? Yeah, last week in the test call, you could see it, but it was kind of just reaching the edge,
Yeah.
turning away from us.
Yeah, there's, according to Stellarium, we don't have a red spot tonight.
Ah,
Of course, with Jupiter, all you have to do is wait a little while. Jupiter rotates in a little bit less than 10 hours. If
okay.
you look at it real closely, you'll notice Jupiter's kind of squashed in its silhouette there. That's because it's wider at the equator than the poles by a good amount. It's because it's spinning.
Somebody just said the International Space Station.
And we have a
just
satellite
passed
right now.
Oh.
Oh, okay. Yeah, we have a spacecraft orbiting Jupiter right now. It's Juno. And it makes long looping orbits of Jupiter, getting real close, like about 3,000 miles above the cloud tops. Takes about a 54-day orbit of Jupiter, and it's been doing that for a couple of years now. And sometimes amateurs will get the images from the camera they put on it, which is sort of a public access camera for keep us amateurs happy. And it will they make long noodle strips on them, and they make those images into a movie, and it's kind of cool, coming in, zipping over the cloud tops and zipping back out. Of course, much faster than the satellite actually does it, but it's really cool. And Juno is a satellite that still uses solar panels, so it's got three very huge solar panels to be able to soak up enough sunlight to generate enough electricity to run it. And I don't know if they've altered the orbit or done anything. Supposedly it was supposed to dip into Jupiter's shadow. They have it set up so it wouldn't enter Jupiter's shadow, but the mission has gone so long and Jupiter's moved so far in its orbit, much farther past the nominal end of mission, that there's dangers of it entering the Jupiter shadow, but in which case the cutoff of sunlight may kill it. That's the only satellite that anybody's been able to put solar panels on as far out as Jupiter. When the Rosetta mission that the Europeans sent to the comet, and that one went into hibernation for a couple of years as they went out towards Jupiter and then we're coming back in to meet the comet, and they didn't have enough energy to sustain it, so they put it to sleep for a couple of years. And it woke up and did its mission. That Churyumov-Gerasimenko is the name of the comet. Surprised I still remember that.
Somebody asked what would happen if you flew into Jupiter.
You wouldn't come out. You can't land on Jupiter because it doesn't have a solid surface on it. The hydrogen atmosphere, which is mostly hydrogen, the clouds are methane and ammonia and other gases, but then it gets hotter and hotter and hotter, and the density of the atmosphere becomes such that you end up supposedly in a hot hydrogen ocean,
Oh,
and it gets worse on the way down. So um, it's nice to observe it from afar.
yeah.
And the radiation belts, because Jupiter has a heck of a magnetic field, because it down inside there is not only hydrogen, metallic hydrogen, um, so it acts like iron as far as holding a magnetic field, and it's got a very intense magnetic field, and supposedly radiation is lethal within inside the orbit of Callisto.
Well, so there's not going to be any missions to Jupiter, at least now with
Nobody
our
gonna be
current
traipsing around.
technology. Yeah.
No. Now, if there is life on Europa, because Europa is a pretty icy planet, and both, especially Io and well, also Ganymede, are all massaged by the fact their orbits aren't exactly circular, and they get tidal squeezes and things like that, and it's enough to raise the internal temperature. So even though like for instance, Io, which is the nearest satellite, is volcanic, and it has huge volcanoes on it all the time going off. Europa is a little farther out, so the heat isn't as much. So it has actually an ocean underneath the ice on it. And if you take a look at Europa, you'll notice there's no craters on it. The surface is pretty much being massaged and changed by that tidal flow, so erases any craters it may have. Ganymede may also have an ocean also, but it does have some craters on it. And Callisto, boy, is pretty banged up. Looks like somebody, like a black marble somebody hit with a ball peen hammer at times. So it's pretty pretty much different characteristics of moon going all the way out. And if you get enough ice and water above you, that's one of the best radiation shields you got. So it could be life on Europa, and that's why they're thinking of an Europa mission. It wouldn't actually orbit Europa, but they'd orbit Jupiter and swing by Europa every few days or so, and look for changes in the surface. Also, it may have geysers like Enceladus on Saturn, its moon on Saturn, and maybe do some easy sampling of the water material without having to drill a 10-kilometer hole down to the water. And so if you're going ice fishing on Europa, you need a really long auger.
Now, somebody asked about the size of some of these moons on Jupiter.
Yeah.
And they vary in size from Ganymede's the ninth largest object like that in the solar system. Ganymede's larger than Mercury. Yeah, it's about
Mercury, yeah.
a little bit more than 32, a little bit more than 32, almost 3,300 kilometers, or excuse me, miles in diameter. I tried to do the conversion. I know them in kilometers. So, it's about 5,300 kilometers.
Yeah, it's a little. It's over 3,000 miles in diameter, so yeah, bigger Mercury.
And the smallest ones are ranging at right about 3 kilometers in diameter. So they're really, really small particles, but they're still classified as moons. Can you see Jupiter on the screen now?
Yep, we can see it. Yeah.
Unfortunately,
get a little hint to cloud bands, but it's wiggling around. Thank you, atmosphere.
Yeah, we've got kind of a shaky atmosphere for tonight, but we're trying. If you look out at the sky, you look out at the moon, you can actually see a little bit of a haze around the moon. We still have a little bit of this wavy atmosphere, and a teeny bit of that smoke is still coming in from the California and Oregon on us. But we do have these dark equatorial bands across Jupiter. Now this is an inverted image here. So we've got these dark bands across here.
Okay.
Great red spot's kind of out of our view for tonight. But there's
Yeah,
the
it's not though.
northern band's been having these dark festoon areas recently on them,
Mhm.
these dark blotches.
Yeah.
So if I get out my hat, maybe I can fan some of the atmosphere out there. No, it's too high up.
Deb asks, when will Jupiter and Saturn be in close proximity for us again? Jupiter laps Saturn about every 20 years. So the last time was around 2000. And then time before that it was around 1980, 81. So about every 20 years will Jupiter and Saturn seem to get together in the sky.
Yep, and they're going to be really, really close. December 21st, December 22nd this year. So they'll be fairly close to each other in the sky.
Yeah. Yeah, they'll be within the telescope field
Yep.
of each other. That'd be cool.
The bad news is it's going to be
Bad thing, it'll be an evening twilight.
December 21st, December 22nd. So if we happen to have some clear skies, it may be possible to see them.
Yeah, sure.
Right. Yeah.
Mm-hmm.
In December. Right. Not quite sure.
And just, yeah, well, yeah, gotta find some place south of here or on the other side of the lake. That helps. Lake Michigan kind of does this in the wintertime.
Somebody asks, is the haze due mainly to the humidity? Probably a combination of factors, really. But
yes,
it might be.
We had some good news and some bad news today. The good news is the clouds kind of split open. This low pressure system that was coming down from Canada actually got pushed north of us, and this bit of a high pressure system that's moving along through the middle part of the states that's carrying the smoke pushed into our area. So that gave us warm temperatures, almost 80 degrees out of my house in Old Mission Peninsula today. The bad news is we've got that warm air moving through, and now it's starting to cool down. The cool currents, wind is starting to pick up just a little bit, and because of that, we're getting distortion in the telescope because of that. So the good news is clear skies. The bad news is a little bit of a wavy image. Going to see the Milky Way. I think, did we pass out all the candy bars?
Mm-hmm.
Yeah, I didn't get any.
That's an astronomer's joke answer to Milky Way. Sorry.
Yeah.
Yeah.
Let's put that out of the.
We will try and get a look at some of the stuff.
We can look some of the parts of the Milky Way anyway.
Right. What a magnetic field is.
Hard to explain briefly.
Can you explain what a magnetic field is? Particles have a positive charge and a negative charge when they were formed. Protons are positive and electrons are negative. Neutrons are neutrally charged. And these charges, both positive and negative, want to attract. So there's a force of energy that wants to cause an attraction between those two. As the electron's in motion and moving, that's how it keeps from being absorbed by the protons. So that existing charge between those two actually creates a bit of a moving energy or moving force called a magnetic field. So that's probably about the simplest explanation I can give you.
The long answer, you got to take some physics classes.
Yes, and experiment with magnets and some little teeny metal shavings or filings. My mom says there's a diamond in the center of Jupiter. Is that true?
Yeah. Problem is, we don't know what's in the center of Jupiter. That's what Juno's trying to find out.
Right.
This spacecraft that's orbiting it. But it's probably iron, like everything else in the solar system. But there could be diamonds in the rough sort of there.
Right.
There's enough carbon down there. The pressure and temperature's right.
And Maggie wants to know how we can see the planets when they're so far away.
Well, as long as there's nothing between us and them and it's bright enough, we can see anything.
We use the telescope to make things look brighter, not necessarily, magnifying them. The telescopes aren't designed really for magnification of things, so we don't really care about that.
Yeah.
We want to bring the light in to make them look brighter so that we can detect them. So telescopes are actually what they're doing is they're bringing in the object, making it look brighter, so then we can increase its size afterwards to see some detail. So that's how we can see these planets, even though they're so far away. The light still reflects off them, and we get an opportunity to see that light coming through the telescope. Such as this wavy image here we call Jupiter.
Yeah. Yeah, it takes sunlight about 45 minutes to make it out to Jupiter and about 45 minutes almost to make it back to us.
Yes, so you're seeing
sunlight
Jupiter,
half an hour and a half old.
yeah, so you're seeing Jupiter the way it looked about 45 minutes ago.
Yeah.
So will we get to see Jupiter, Saturn, and Mars? We're taking a look at Jupiter right now. I'm going backwards on some of these questions. Sorry, I'm falling a little bit behind on the questions.
The question in the chat about could tourists coming to Traverse City see programs at the observatory at any time? Probably not at this time, but
no, because with this this coming up with this COVID issue, as I said, I couldn't have even my students look through the eyepiece of the telescope and get it to do it safely.
right.
Because of the delicate optics in the eyepiece, we can't just wipe it off with an antiseptic swab. If we did that, there's a special coating that's used for anti-reflectiveness. And after you wipe that eyepiece with that so many times, you wipe completely off there. So I thought about using an ultraviolet C-range ultraviolet light, but it's carcinogenic, so it wouldn't be good for my health. So that's when we came up with this camera idea for the next best thing. Now, stay tuned because tonight is the kickoff to reopening our public viewing nights for the general public on a once-a-month basis.
Oh.
Yes, because we had an excess of, I think we top somewhere around 160 attendees or something like that tonight. I'll go back to the recording.
I think it was close to 180 at one point.
Okay, so that makes for a really good open house viewing session. So since we can't do it with you looking through the eyepiece of the telescope just yet, until we can get past this with, I'm not so sure it would take the vaccine. I think it would take inoculation to really help us with that. So, but until we get something like that out there to where we can safely return to, face to face, this video camera is going to be the thing we're going to use. So as it comes along, we'll post the dates and times as early as we can on NMC's website for the observatory, as well as on the Grand Traverse Astronomical Society's website. But I'd like to start returning to open viewing sessions where we can take a look at things that the observatory can see and send it to you in the comfort of your living room. Are the northern lights visible for this evening? That's a really good question.
Jerry, I was looking up on space weather.
Yes.
And, there is a bit of a storm right now. The planetary K index is 5 and the solar wind's about 510 kilometers per second. So there's a little storm going on.
So I wonder, I'm looking to the south. Can anybody peek outside and take a look toward the north? Do we have some northern lights out there?
Yeah, we're going to have to be pretty bright to compete with the moon.
Yeah. Right.
So that's typically the case if it's if the moon's very full. It's gonna be hard to see.
Well,
Right.
I've seen
harder.
northern lights on a full moon night. But they are really have to be really, really bright.
Gotcha.
That's back in the old days when we used to have a lot of sunspots on the sun too. We're at a minimum. Matter of fact, the next cycle, cycle 25, is just starting up as cycle 24 fades, and it'll be about 4 or 5 years before it peak again. And the guessing now is it's going to be a worse or a lower peak than the last one, which wasn't a very active sun. And first peak I knew about as an amateur astronomer was back in 57, 58, and that was the greatest peak of sunspots in modern history since the Maunder minimum. And even down at Grand Rapids, we had a lot of northern lights. But this last one, I haven't seen much more than a haze on the northern horizon. My Aurora spotter done retired. Bill Hathaway, he usually puts out beehives at night. And if he sees an Aurora, he calls me up, but he doesn't do that anymore.
Right. I noticed in the chat.
So I don't get heads up.
I noticed in the chat
other than
that,
from space weather.
I noticed in the chat that Beverly said she saw them 2 nights ago here in Bethel, Alaska. So
Imagine he's more often.
You're zooming in. You're zooming in from
yeah.
right now. Is that right, Beverly?
Sounds like it.
And how far have our satellites traveled up through our solar system? We've got some satellites that have they're exiting our solar system and the influence of the solar wind. So they're beginning to leave our entire solar system and heading out into what would be considered the realm of the interior of what's called the Oort cloud, or where comets are located.
Somebody asked about Voyager 1 earlier, if there was still any contact.
We're still getting a signal from those Voyager spacecraft. It's very, very.
Yeah, they're still looking at them.
Yep, and it takes an awful long time for that signal to return to Earth, but they are still sending a very small signal, a very, very low frequency signal, low energy signal rather, that we are picking up, so we can tell about where they're located at. So they're still alive as of the last signal.
Mm-hmm.
Whether they've
they still monitor them every day, or at least every week.
Do we want to take a chance and see what Saturn looks like?
Give it a shot.
Any nods?
Give her a whirl.
Let's see what happens.
Everybody asks you if you see the rings on Saturn right now. The rings is what you can see. It's finding a planet in the middle. It's can be difficult. Oh, let's see here.
Got to see the rings last Friday. Pretty distinctly.
Yeah. Yep. The seeing is not the best tonight. There we go.
Oh, let's see.
I'm cheating. I'm following along in Stellarium.
Okay.
It doesn't have to go too far.
We'll give this a whirl and let's see what happens.
See what we can see.
Need to make some adjustments here before we go.
There we go.
We can pick it up and we'll start with that.
Beverly said she's a Sleeping Bear Dunes fan. Well, happy to have you. Oh, look at that. Oh, blinked in.
We'll see if
Lindsay,
Bob-
Lindsay got what she was hoping for there. All right.
Okay. Now let's make some adjustments here and let's see what we can see. We'll start around there and we'll pull this down. A little too far. Our atmosphere is playing with us
Yeah, it's
tonight, but
It blinks into pretty clear focus occasionally, though.
right.
yeah.
And if you look on here, if you can see my cursor there moving around, this darkened area down here is the shadow of Saturn covering the rings.
Mm-hmm. Now, how many rings does Saturn have? Is my naive non-astronomer question.
Oh, well, let's see. They're up to G.
G, in terms of labeling them, those are regions now. So each
Yeah.
region, alphabetically, ABC, varies in width and mostly made of icy particles. And these icy particles are anywhere from small, teeny little rocks up to about the size of a house. Now, the rings across are nearly the distance from the Earth to the moon, but they're only about 100 meters thick, so they're paper thin. And unfortunately, with that moving atmosphere and a little bit of the moon out there, this might be about the best image we can get right now.
Pretty good.
Yeah.
Saturn, the married planet.
Yeah.
The one with the rings. And we've got Natalia. She joined us. I brought her into the panel portion of things.
Welcome.
I don't think I can compete.
What makes the rings?
Yeah, a combination of. Go ahead, Bob.
It's a hegemony of all the other particles. They keep you in line.
Yeah, a combination of gravity and something called centripetal force. So as the planet itself is rotating and spinning, objects close to it want to continue that, slight gravitational attraction of things and move around with it. So Uranus has rings too. And in fact, all four of the gaseous planets, Jupiter, Saturn, Uranus, and Neptune, all have rings. Jupiter's rings we don't see because they're mostly dusty stuff. Any of the icy particles that could have been there have long been melted because of Jupiter's strong magnetic field or pulled into Jupiter. The dusty stuff, as well as the fact that Jupiter doesn't have much of a tilt. Earth's tilt is 23.5 degrees. Jupiter's tilt is about 5 degrees. So those rings are generally face onto us. Saturn, we see the rings like this because they're mostly icy particles, and Saturn has a good sized tilt. It's about 27 degrees. So are the rings constantly being built up? Actually constantly being pulled into the planet. The inner portion of the rings, we found it out from Cassini, is that those particles are being pulled down into Saturn. So, eventually what's going to happen is the rings will disappear over time. Any satellites, moons.
Yeah, the reason rings are so thin, is that if any particle got up with any kind of inclination, it'd have to pass through the rings twice on its orbit of Saturn, so they get beat down quite a bit into a pretty flat plane. Although if you see some of the pictures that Cassini sent back of what's going on in the rings, there's small satellites in the rings that create ripples and things and little gaps in the rings. It's all quite dynamic in there.
Lori had asked, why is it yellow? Why is it, which is took the words out of my mouth here. Why are we seeing it in that color here?
Well, Saturn's actually a bit of a light tannish, maybe a very, very cream colored. The camera's accentuating the color. It did the same thing for Jupiter. So, and it's due to the type of camera system that we're using.
Yeah. And we have smoke in the atmosphere, and they're low in the sky, so not as whitish. Usually the rings come out much whiter than the planet, especially at opposition, which we had there a few months ago.
Yep.
And so the rings can be brighter than the planet.
And
the rings are starting to go edge on to us. You can see Saturn stick its the planet above the rings a little bit, so they'll be getting skinnier and skinnier as we go on the next few years.
Yep. So the ring tilt was at a period of time, just last year and the year before, you could actually see the ring go all the way around the top portion of Saturn. Now we've got the image of Saturn is actually right here, this darkened area, this crevice right here is where Saturn's shadow is blocking the rings. So it's beginning to tilt back, will go edge on. When Saturn's rings go edge on and you show somebody Saturn through a telescope, they look at it and they go, that can't be Saturn. It doesn't have rings. Well, when you look at it edge on, they're paper thin.
Interesting.
They just disappear.
Kind of a curiosity.
Rings.
It's a curiosity question here. If there were to be life in space, where do you think it would be? What planet? Well, you were already talking about Europa is not a planet, but anywhere else that scientists
that
think
and Enceladus maybe.
Actually, I think we've been looking to see if we can find some life on this planet.
There's life on this planet, intelligent life. I don't know about.
Yeah. If we're looking for life forms, as we somewhat have defined it, we need that life form to exist because of something of the consumption of liquid. So water is the first thing that comes to mind. So Enceladus is one that has liquid spewing out of its southern regions. So that's a possibility. What's not to say that the life forms could live in the methane areas. So Titan's another possibility.
Titan is a real weird possibility.
Right. Europa is a possibility. It doesn't have to be water on the surface, or could it be liquid form water below a frozen, crusted surface. And not to mention the new discoveries on Venus. While in the atmosphere of Venus, I still have a question about that, because the surface of Venus is 800 Fahrenheit, close to 900 Fahrenheit in some places on a continuous basis. It doesn't get any cooler than that. So anything on the surface is going to have to be able to survive being melted. If it's in the atmosphere, it would have to be in an area above where it rains sulfuric acid, because there's thick carbon dioxide, heavy thick carbon dioxide atmosphere. That's about 90 times the atmospheric pressures here on the surface of Earth. And then it rains sulfuric acid, so it's got to be able to survive that. So
not life as we know it then.
Not life as we know it. And is there life form there? Don't know. Or it could be other things that's causing that phosgene that's detected in that
phosphine,
atmospheric area. Well, there are some other possibilities.
Well, there's some speculation that Venus in the early days of the solar system was more Earth-like, and life could arose there. And as it got more untenable on the surface, what was in the atmosphere kept going. That's one theory that of how it got started.
What's 800 degrees due to phosphenes? Just break them down?
And break it. break it down probably.
Yeah.
Break down almost anything.
Yeah, that's I guess what Jess had been asking. What new discovery on Venus is the phosphine? You saying some kind of
Well,
gas that indicates possibly life?
Right.
Yeah. Well, if you're up about 50 kilometers above the planet, it's also, it's fairly decent temperatures, other than the stray sulfuric acid molecule. Can't breathe this stuff because it's all carbon dioxide, but the pressure and temperature is amenable to somebody who can handle the carbon dioxide and running into sulfuric acid droplets. But so some of the we have NASA's looking at 2 possible missions right now to Venus after being ignored for a very long time, a quarter century at least. One to drop, both of them dropping through the atmosphere. One of them looking at the atmosphere, and the other one, once it gets a little bit lower, to take photographs and of in various spectral ranges of the surface of Venus. Now we have, radar images from the Magellan probe back in the late 80s, and that's pretty good, except it's relatively crude as far as detail. If we can get photographs, sort of like we have from Titan when they dropped the Huygens probe down on the planet, on the moon, and got real up close and personal, where we could see the finer landforms. It would be nice to do on Venus. And somebody's trying to come up with a purely mechanical rover that can hang around in 800 plus degree Fahrenheit temperatures. I'm not sure how it would communicate with us because all the electronics is fry.
Right. Good luck with that. Good luck with that, because one thing the computers do not like, and it's heat. So you're going to have to be able to protect the computer. But if you protect the computer with enough shielding to protect the heat, then you have the problem of the computer system talking with us. So it's too much. So coming up with a rover that'll do something like that, and because Venus is about the size of the Earth, so if you land something on it that you wanted to take off later, you're going to need the same kind of propulsion that you have here on Earth to get it off the surface. Mm-hmm. So that's why it was so difficult.
And even worse, because you gotta go through all that atmosphere.
Yep.
It's hard on the Earth to get off the Earth through the atmosphere. Just think of it, if you're launching from a kilometer down in the ocean to try to get that off.
Yep. Okay. Any chance?
I think the fun part of Venus is the clouds.
Yeah. Somebody just typed into the chat, any chance of seeing Mars? And I was just about to ask, have we seen enough of Saturn? I think Mars is high enough in the sky. Let's go take a look. What do you think?
Red planet.
All right, let's go to Mars. Elon says go to Mars.
Let's do that. I'm gonna mute myself again because I have to rotate the dome around. I don't want all the noise blasting everybody's ears out. So let's do that. Let's try and go to Mars.
All right.
All right. Okay.
Now you were talking about chances of life being low on Venus, but I mean, maybe it's life that I have no evidence for this, but it just seems like all the aliens that in science fiction are very humanoid. What if life isn't anything like that? What we could, imagine.
Yeah,
it's not going to look like us.
Well, some folks are speculating that something in a world where it's dominated by a thick atmosphere like Jupiter or Venus have sort of balloony creatures that float in the atmosphere.
Right. And they don't,
that would be one of the things that we do. If we went the first expeditions to Venus, if we're going to send people, we'd, somehow get them into a blimp or something like that to float through the atmosphere.
Right.
Like I say, other than if you're above the clouds, you're 50 kilometers up, where you have the atmospheric pressure almost the same as Earth normal, you'd be there for quite a while on a stable platform for launching anything.
Right.
But
But it seems like we're always looking
yeah,
for water and, you know, things that we recognize as essential for life when, like Adam just said in chat here, that could be silicon-based life out there. You know, there's
yeah,
something we might have to think outside the box of what
yeah.
what we
I
consider
think we got
life.
probably have to find it and say, oh yeah, now it opens up. You know, when you only have one example of life, you get sort of tunnel vision on that score, because we
Right.
have no idea of the possibilities.
Yeah.
Okay, we have let's see, Mars is, oh, in the sky is it here? It's 18 degrees up. So
And
it's
yeah,
still
Adam,
kind
you're
of,
right. It's loud cranking noises. He's trying to spare our eardrums.
yeah.
Doesn't work well with our microphones. Comes through loud.
No.
Is there water? That's another question that was earlier about Venus. They said that life on Venus would exist in the upper atmosphere with about 1 atmosphere pressure. Blah, blah, blah. Is there water in that area? Up in the atmosphere?
There may be.
Whoa, got something peeking in the frame.
Bright Mars racing. Turn on. One of the things you find out if you look at Mars through a telescope, besides being tiny, it's bright. It's much brighter than Jupiter and Saturn is, and which makes it kind of hard to map. Last time I did any really good mapping was like in 1973
Oh,
with
wow.
a 6-inch telescope, and used. There we go. Ooh, it's trying hard to stay around here. Yeah, it's inverted. Every once in a while, you can see sort of a white spot on the top, and that'd be southern polar cap. Gives us an inverted image.
Mm.
So
So there is ice.
now that I've stopped making noise, here the wind is actually picked up around the dome, so it's kind of blowing hard outside the dome just a little bit, you know. So no wonder the image is a little bit more distorted right now. Trying to see if I can settle it down by adjusting this. Can you guys hear that?
It's
That's
not
wind.
loud at all, Jerry.
What was that?
It's not loud at all, really.
Oh, that's the wind blowing around the dome.
Oh, okay.
Yeah. The moons on Mars. To see the moons on Mars, we have to use something called an occulting disk, and actually it's a filament that we put across the eyepiece. It's like a thread. And what we do is we block out the brightness of Mars, and then we're able to pick up the moons. The moons are really, really small on Mars.
Looks like that polar cap is popping up every once in a while.
Yeah, and that seems
It's
to be
flickering in and out on top.
Yeah.
I brought down this, shrunk it down just a teeny bit more to maybe help the visibility of some of that versus enlarging it. And if I make it bigger, it seems to amplify the distortion a little too much. Our atmosphere needs to settle down out there.
It's getting there. So what are your guys' thoughts on missions to Mars and all the people that are volunteering in that whole endeavor. You mentioned Elon there. Yeah, the moon's closer.
Elon, well, there's, he wants to get there, although he will, is going to help NASA with the moon bases and things with Falcon Heavy bringing supplies to there's going to be a lunar space station. And not for the first few trips to the moon, but later on.
Yeah.
Supplying those. And he's also one of the 3 landers, and they're going to use a Starship as a lander, although I can't see it being for the earlier flights. It'd be a great cargo carrier for once they get a moon base established.
So moon first.
Sure hold.
Yeah. Yeah. Use the moon first as a
moon first.
pad. Simply because we can, with the same propulsion, we can take 6 times as much material with us. And again, we really need to take water. That's the big thing. Even though there's water on the moon or on Mars, we still have to take water with us for us to last, for that long duration trip. So 2 important things we need to take, because it's going to take probably between 9 months and 10 months to get there. You don't want to go too fast, because you have to stop when you get there. So we need to take a lot of water and a lot of Yahtzee pads.
Of course, the fun thing is water is worth its way more than worth its weight in gold on the moon. If there's water there on the moon we can get, it'd be great.
Yes.
Now, are they still?
Except you got to go to the South Pole, where it's in the shadowed craters at the pole. The moon doesn't have much of an axial tilt, unlike the Earth. So there are permanently shadowed craters, and there was some suspect, especially on the South Pole, that there was water there, because some spacecraft kept picking up excess of hydrogen as they were flying over. And when the lunar reconnaissance orbiter was sent, they sent another spacecraft with the last stage, and they targeted that for the South Pole of the moon, one of the craters. And there was another little spacecraft that was right behind it to pick up and analyze the material that was kicked up when this last stage punched into the crater. And supposedly, even though nothing was visible from the Earth, they did pick up signals of some water and some other hydrocarbons. Problem is, I don't think it's pure water. It's going to be kind of gunky. You're going to have to to purify it, I think.
Right. And somebody was asking in the chat, does the wind affect the light rays? Well, actually what it does is it affects the ability to see the light coming through. And the changing atmosphere has a tendency to distort these images, because the light's trying to come through moving air currents. So much like, not with the same viscosity of water, but much like trying to see something through water. As water is moving around, it distorts an image below it too as well. So we're seeing that distortion here based upon a lot of changing atmosphere right now. So the changing atmosphere, like I said, the wind is blowing a little bit stiffer outside the dome right now.
Is the idea, as far as going to Mars and the radiation from cosmic rays and solar radiation, is the thought still to use water to absorb those rays as a shield?
Yes.
Water works better than lead. Lead gives you a secondary particles. Water slows them down.
Right.
It's a moderator using reactors.
So you'd have to have some kind of water-filled suits.
Water
Uh,
jacket. Well, you can drink it as you go, I suppose. But
Yeah. Now, actually, what they do
uh,
is on the spacecraft constellation that we're planning to go back to the moon with, the outer skin of that covers almost like a thin radiator, like on an automobile. That water flows through that thin radiator, and what it does is the water helps to absorb the high energy particles, energy, material coming from the sun. As it hits the water, it basically tries to split it up, so it changes the water into oxygen and hydrogen for a fuel cell.
Hmm.
Is the Viking spacecraft still sending signals? I don't believe so.
no, they pretty much went kaput after a few years.
Yeah.
They did have the landers did have plutonium generators, but they didn't only last a couple of years.
So, but every once in a while we can pick up the polar cap, little white beanie up near the
Yeah,
top
Tom.
here. And if you look carefully, you can see there's still a bit of this dark basin area. And this would be inverted, so that's a South Pole cap that we're seeing. So that atmosphere is really moving around tonight.
Yeah.
It would give us something to do with them other than dropping them on ourselves. Oh, we're talking about the nuclear stuff, right? Yeah, got it.
Yeah.
Yeah, right now there is, it's populated with inhabited by robots right now. This is true, and we're sending more to Mars. It's a fairly big sized
Yeah,
planet. So I don't think they're going to run into each other.
Yeah.
So we want to try and learn as much as we can about that. The more we learn about Mars, the more we can learn about the Earth here. What's the oldest spacecraft on Mars?
On Mars, it'd be a Russian lander that landed in '71.
Yep.
Forget the name of it. It crashed, and well, it lasted for about 10 seconds, something like that.
Yeah.
They beat us, luckily in '71 we sent a north orbiter of Mars, and when it got there, there was a planet-wide dust storm like we had a couple of years ago, and it was able to outlast the dust storm and actually get some pretty good pictures. Mariner 9. There's a whole flotilla of satellites around Mars right now. Plus all the old ones that are still orbiting the planet. So let's see the live satellites. I think we have Mars Odyssey, probably the oldest now. That was 2001. That's why they named it Odyssey launch. Mars Reconnaissance Orbiter. We have Maven. Europeans have Mars Express. The Indians have a satellite orbiting it. Russians never had good luck with Mars. This stuff either crashed or died. They had better luck at Venus.
Yes, and we've had terrible luck with Venus as far as the lander, so we kind of switched.
Well, we didn't really really try a lander. That's what we did. Yeah, we did. Well, we did have the Pioneer that sent something like 4 atmospheric probes, and some of them landed. The cool thing on Venus, you don't need a parachute to land. The atmosphere is so thick.
Right.
And Russians found out that the hard way.
Yep. Do we believe that
they tried to use parachutes all the way down, and they just got about halfway down in the atmosphere, and the heat got the probe?
Yeah. Questions in the chat. Do we believe that gravity is very much the same as it is here on Earth? Actually, just not quite a 1/4 of the gravity. It's far as gravity.
Yeah, I think we're about a third, something like that. About
Yeah, something around about a
Third.
third or so.
38%.
How much of the fuzziness is atmospheric versus camera effect? Probably about 90% fuzziness due to the atmosphere. 10% camera.
The atmosphere.
Yeah. So, as I said, I can hear it up here quite a bit. I'm not sure if it's being picked up by the microphone, but the wind is really whizzing around out there right now.
Yeah. What is the newest spacecraft on Mars? At Mars is probably the Indian probe. We didn't, or InSight. We have a lander InSight that went last opposition. It's one of the newer ones on Mars.
The last opposition was that.
You get their little. When Mars is closest to us, when it's opposite the sun in the sky, it's called opposition. And we're coming up for opposition here next month on the 13th. And closest approach is actually on the 6th, a week before then. But the reason that's true is that Mars is on its outbound part of its elliptical orbit. So it's a little closer, about a week before opposition.
That's what I was
Those
about
occur every 26 months on average.
I was going to ask that. So logistically, to plan for a trip there, if Elon was actually going to do it, you have to time it with that close. You wouldn't want to try it just any old day. You got to make sure it's
right
closer.
Right. And you got to launch a few months before opposition to land a few months after opposition. Because you can't get there, you can't wait until, it's closest now, let's go. That don't work.
Right. And then once you're there, it's not.
You got to sort of lead your target.
Right. And then remember, once you get there, Mars's orbit's almost.
You can't get back.
Its year is almost twice of what Earth is.
Oh.
So by the time you get there, Earth is orbited around the sun, right? So we're out of position for a quick trip back. So you might as well stay there for a short period of time and then take a long trip back. So plan on, not just 9 months there and 9 months back. Plan 9 months there, at least 6 months on the planet, and then 9 months back.
It's a commitment.
Yeah, if Venus is in the right position, you can sort of use Venus as a gravity assist back, but it's not always in the right place for you.
Right.
It's only like about a tour in the Peace Corps, just a very different environment to go to.
Yeah, it's kind of like a weird 3-dimensional space billiards, how they move around there when everything's moving. Yeah, it's really doing a dance, ain't it?
It's doing a dance tonight. I was hoping it would, stay stable, and we had to lose something.
Yeah.
So we lost a little bit of the atmospheric sea, and it's jiggling around on us in exchange for some clear skies.
Clear skies.
Some somewhat warm temperatures.
Okay.
So I guess I'll take the clear skies and the jitteriness versus trying to fight the clouds.
Okay.
And have it.
Yeah. All right. Okay. It was wrong before. It's now 22 degrees up, so it's about as high as Jupiter and Saturn are.
Right. So we're starting to get a little bit more of a stable to it.
So we're coming up on 11. I was about 10:47, but I just want to encourage people that want to stay on. You guys are, Jerry, Bob, the rest you're staying on for a while yet, right? And I'll be having to take off, but.
Well, I'm gonna stay on for a while. I'm watching this from my bedroom, so I can. Don't have to go far.
Yeah. Well, I just wanted to say. Just wanted to say that this has been great, and I'm thankful for everybody that showed up, and I hope we can do this again for the 50th anniversary of Sleeping Bear Dunes, October 21st, or near then, whichever the Friday before or something. I would hope to have all you guys come again, and maybe we'll have some better seeing. Even then, conditions improve.
Yeah.
And it's been great to do this for Sleeping Bear Dunes to help them celebrate their 50th anniversary.
Yeah.
Sleeping Bear Dunes has been doing some wonderful things uh, for the community, the public, and everybody around the state for a long period of time. It just to let everyone know, it is a wonderful place for dark skies, for going out and viewing the Milky Way. I tell my astronomy students, I says, if you want it, you have to draw your 15 constellation objects. You can head out to Old Mission Peninsula, the scenic turnout out there. Chateau Grand Traverse is a good place to do it, or go all the way out to the lighthouse. There's a few places, if you go east, you have to get between Williamsburg and Kalkaska to get dark skies. Going south, you run into problems. Sometimes you got to get between Fife Lake and Manton. If you get too far south, you get Cadillac. If you really want, if you're adventurous, head out to the dune climb. But if you do that, from past experience of having students go out there, make sure that you go out there and you stand outside and look at the sky while your eyes are becoming dark adapted. Don't sit inside your car unless your eyes become dark adapted and step outside, because you'll get lost. There's so many stars out there. Sometimes the bright star constellations are difficult to find because it is a gorgeous place.
Yeah.
Um,
Yeah. But the Milky Way is really great out there on a dark night. It's really super.
yes.
No moon. It's great.
Jess said, come to the UP for dark skies. I hear you. I went to school up there. You can get, there's plenty of dark sky up there.
Yep. A long time between towns.
One of many reasons to go up there.
Yep. And Natalie, you still with us, right?
I'm still here.
Okay.
I love all the dark.
The Dark Sky and the Dark Sky Park Initiative. I've got a meeting coming up with John Barentine and Adam, who's taken over for the Dark Sky Park designation, to continue with that paperwork and get the initiative going.
Yes, I met with Julie from the Park Service today. So I got all of the historical context, all the documentation, and kind of previous roadblocks, and a plan to obliterate the roadblocks.
That's great.
I'm excited. A lot of work to be done.
Yes.
Yes.
Well worth it.
Mm-hmm.
It will be well worth it.
We have a question for opportunity for Milky Way viewing better tonight or during the 50th in October. It will be better in October if we don't. We have a first quarter on the 23rd, sort of like tonight, but if we can actually do it on the Wednesday, we can't, which we really can't because telescopes are being used for class. But do it the week before. We got a new moon. Probably
Sounds
last
good.
time to see the summer part of the way.
And
Well,
did you guys say too that we started an hour earlier? Oh, sorry, Bob.
Yeah, we normally start an hour earlier, and in October, mainly because sunsets earlier. That's the thing.
Yeah.
And so we'll have the planets first, like we do now, but we'll be almost 2 hours in sidereal time earlier. Plus, starting at 8, it's even a little bit half of that, but it'll get Mars up earlier, and we start with the planets. By the time we're through with the planets, it'll be definitely dark. Dark.
Yeah,
The Milky Way. Now, the problem with seeing the Milky Way is we have such a small viewport. What it's going to do is allow us to see more what we call deep sky objects, which are little things that live in the Milky Way, like star clusters and nebulae. And in October, we get to see the Great Andromeda Galaxy. That we're going to get real close to in about 4 billion years. And You shake hands a little bit. And got a whole slew of more pieces of sky, but I think we'll still have enough left to see some of our summer friends. We're going to lose the southern Sagittarius that month, but we'll have Ring Nebula, the Wild Duck Cluster, which is always fun, and some of the cool things around Cygnus, and of course the Great Hercules Cluster.
Galaxy S1 here said they came late. Did you show any other planets besides Mars? Yes, we had a little tour here. Sorry you missed out, but got to see Jupiter and Saturn. Started with the moon close up. So better luck next time. You got to get here with the early birds and you'll get to see it all. But yeah, there's always next time.
But yeah, next time we'll have real slight moon.
Close-up of constellations.
Closest of
the cameras are too narrow. So
what you can do is if you're online and you have a pretty good bandwidth, is go to stellarium.org. It downloads a very nice planetarium type program which you can learn your constellations on, and I'm running this right now as sort of to orient myself of what's on the face of Mars right now. And it does a pretty good job of showing you constellations pretty realistically. Not as good as the real thing, but we got to find a way of hooking up a camera to a very wide angle camera optic to do that. That'd be great if we could do that.
Well, guys, I gotta take a leave here and bow out. Thanks so much for having me, and have a good rest of the night.
Okay, I'm going to try for one more object for us here before we.
Oh no! Right when I leave.
I'm thinking people have been wanting Milky Way stuff. Let's see if we can pick up that globular cluster in Hercules. So, but you'll have to give me a few minutes because I need to rotate,
switch
cameras. So,
so he's good. And he'll turn off his microphone so we don't hear all the banging and booming and
then
the dome.
And then David will be in touch.
Yes, sounds great. Jerry, Bob,
all right.
The rest.
Okay.
Natalie, and Natalia, sorry. Take care, everybody.
Bye, Dave.